Yes, class. Good evening, Ahmed. Yes, good evening, all. Am I audible?
Good evening, ma'am.
Is it audible to all of you?
Yes, ma'am.
Okay. So, Anushka, Astha, Ahmed, and Jeeva. So, yesterday only we had started with the electromagnetic waves. So, electromagnetic waves basically have electromagnetic waves lie in the electric field and the magnetic field. These are those kinds of waves. Now, mainly it was said, and we had yesterday only seen this, that whenever time varying electric field is there, means an electric field is there which is depending upon time, that will give rise to magnetic field, and when time varying magnetic field is there, that will give rise to electric field. Fine. So this was the order of the spectrum that was involved. This I'll discuss it today. And definition we had seen, and this we had seen. Electric field was perpendicular to magnetic field and direction of propagation. So till the time other students are joining, do one thing, note it down, because I think yesterday I didn't give you enough time to write it down. Write it, then we'll discuss the two equations. Quickly write it down. Written till here. So this was about the electric field and the magnetic field. Both were perpendicular to each other, and it was also perpendicular to the direction of propagation. Now, one more thing, the main equation that we didn't discuss yesterday, we couldn't discuss it, the main equation that is involved. So that equation is similar to what you have already studied. Electric fields equation I'm writing now. So electric field is basically E naught sine kx plus minus omega t. This is the equation of the electric field.
Ma'am, can you show the previous notes?
Yes, I'm sure. Let me just discuss this and I'll show it. All right, now let us just first discuss this, what is meant by each term, and I'll show you the previous note from the starting, because some of you have joined late. So because yesterday we couldn't write it, no. Now see, what is the meaning of each term in this main equation? E is equal to E naught sine kx plus minus omega t is the equation which you have to remember the way you have been remembering your waves and oscillations equation. This is just an example of that only. Now E is what? E is your simple electric field. E is electric field. So electric field in which your wave is propagated. This is the electric. Now E naught is what? See, when we did AC, what did we discuss? When we did AC, we had seen for EMF's maximum value of all the values that were present. You had one maximum value which we called as E naught, or when the current was there. So because of the rotation of AC dynamo, or the coil was kept keeping on rotating. So for that time, we had different values of current. Among that value, we had chosen one of the values that was having the maximum amplitude. Similarly, this is also the same case. Since your electric field is variable, you will be having different values of electric fields for different intervals of time. So right now also, for some amount of time, for some interval of time, you have certain value of electric field. Out of all these values of electric fields that have been obtained for different time instants and different time intervals, the one which is having the maximum value, that is known as peak value. So this is also peak value, or you can say amplitude. Sine is your normal sine function, which you have for the trigonometry, from the trigonometry. Same, sine, cosine, that's it. Now, K is what? See, we are continuously referring to a wave. We are continuously referring to a wave. So if we are referring to a wave, so definitely we'll be having certain wave parameters. Now see, if this is your wave, so this entire length which you have, this is known as wavelength. So how will you connect wavelength with the main equation? So to connect your wavelength with electric field, you have this term which is called as angular wave number. And this is simply just a constant. Physically, this has no meaning. Like you cannot observe it, you cannot observe phenomena to angular wave number. No. It is just a term, a constant term that has been created. So angular wave number is what? This is related with lambda, that is the wavelength of a wave. So K is equal to 2 pi by lambda. K is equal to 2 pi by lambda. This is a formula which you all have to remember it. K is equal to 2 pi by lambda. Now see, this gives you what? This tells you about the axis. As in, if it is written x over here, that will show you that this is the x-axis. If it is written y over here, that will give you an idea that the y-axis is involved. And if it is written z over here, then you can easily conclude the fact that z-axis is involved. So which axis is involved means what? Where your electric field is lying. So axis of electric field mainly. This is telling you the axis of electric field. Now plus minus both are written, but in your equation you just have a single term. So how am I writing both plus and minus in the same equation? It is that if your wave is traveling along positive axis, be it x, y, z, whatever. I'm not referring to any of the axis. I'm just referring to the plus minus. If your wave is traveling to positive axis, positive x axis, positive y axis, or positive z axis. If it is positive, you put a negative sign. It's opposite. So positive sign for negative axis and negative sign for positive axis. So if I write down, let's say minus, if I write down z minus omega t, so that will give me idea it is traveling along positive z axis because minus is written like this. So plus minus you have to put accordingly to the axis that you have and opposite to the direction of propagation. So this basically tells you the direction of propagation. This is there to tell you about the direction of propagation. So put a plus sign if your wave is traveling along the negative axis, put a negative sign if your wave is traveling along the positive axis. Simply, this is just the rule. Now, omega is what? Omega is angular frequency. Angular frequency is same. Omega is equal to 2 pi nu, which in terms of linear frequency. Here you will be using this as well, 2 pi divided by capital T. Now capital T is what? Capital T is the time period. Time period of what? Time period of this entire wave to complete this journey. When all the particles of the wave have covered this journey, that total time duration, that is known as time period. So here also, and T is any time instant for which you are calculating the electric fields. So this is the equation, how you write it. Now, even if I want to write the same equation for magnetic field, I'll just write B is equal to B naught sine kx plus minus omega t. Rest of the things will remain the same. And see, take it as a generalized, standardized equation. This is a standardized equation. This means what? It means if I give you some other equation, you have to compare it with this main equation. So for magnetic field also, you will have the same thing. Okay, I have written this. So can anyone tell me in which axis direction completely the wave is propagating? Equation is written in front of you.
Positive x-axis.
Positive x-axis, yes. Positive x-axis. Because negative sign is mentioned. Good, right. So this way you have to write it. Before starting with properties, yes, firstly, those who were late, quickly write it down. Just take the screenshots of these because it will take a lot of time then. And properties of EM is very important from today's class. And questions from this part that we have just discussed, that we'll do later. Once we do the properties, after that we'll do. Yes, I had sent the scores, but I could only receive, I think, 3 papers. Imad, Ryan, no. Imad, Anushka, and one more person was there. I think I had sent you those scores, no? And Zaid, you were added today? Rayan, Imad, and Anushka, yes. So if all other students are there who have submitted their sheets and I have not checked, please resend it because I couldn't find other sheets.
Ma'am, you called?
Yes, who is this? Zed.
Yeah, ma'am.
Yes, Zed, I was asking you, have you added, are you added?
Yeah,
on-
yeah, ma'am. I
Okay.
mean,
Okay. Okay, let's discuss the properties of EM waves. This properties portion is very important. See, first property is very easy and we have discussed it, that electric field, magnetic field and direction of propagation all are perpendicular to each other. That we have already discussed. So that is one of the major important properties of EM waves. Then you have electric field and magnetic fields ratio, which is equal to speed of light. This is actually, if you remember Lorentz force which we did, and the magnetic force QVB, we had no QVB, this was equal to the electric force. So if you equate both of these, Q gets cancelled, ratio of E by B gives you speed. From here we conclude the fact that ratio of electric field and magnetic field both are equal to the ratio of the speed of light. It means that EM waves travel with the speed of light. What's the speed of light? Magnitude, speed of light. Yes, class?
9.8.
No. Speed of light in free space. Yes, Ahmad. Just try.
The equation one or value?
Value, speed of light in air. Speed of light in vacuum. What is it? Yes, class. Others. Ahmed, Astha, Anushka.
3.8.
3 into 10 to the power 8. Good, Razan. 3 into 10 to the power 8. Class, please remember this value. This value is a very basic value. I was supposing all of you must be remembering it. 3 into 10 to the power 8. Fine, that is the speed of light. 3 into 10 to the power 8 meter per second. This is the speed of light. So EM waves travel with the same speed of light. If ultraviolet radiation comes from the sun, it travels with the same speed of light. That's why the rays are able to reach us within this exact duration. So EM waves travel with speed of light. This is the second property. Third property is speed of EM wave in vacuum. So that equation which we have, speed of light, that is 3 into 10 to the power 8 meter per second, that is actually proven using this equation. Mu naught we have done, permeability of free space, no, we did it. And epsilon naught also we did in first lesson when we were discussing electrostatics. There we did discuss that this is permittivity, and it is the factor that governs the dependency of the force on different types of media that are present. If the value of force in one medium is something, then in the other medium that value gets changed. Fine. So C is equal to 1 by under root mu naught epsilon naught. Mu naught is permeability, epsilon naught is permittivity. Fine. But if you put in all the values that you have, if you put in the value mu naught, what is the value of mu naught? How do we write it? Yes, class. Anushka, say.
Four pi.
4 pi into 10 raised to minus 7.
Yes, 4 pi into 10 to the power minus 7. See, mu naught's value. Mu naught is 4 pi into 10 to the power minus 7. So 4 pi into 10 to the power minus 7. Multiplied by epsilon naught. What's the value of epsilon naught? Yes, from your electrostatics, you all don't remember the value of permittivity in free space. Epsilon naught's value, class. You use it in Coulomb's law.
Is it 8.85?
8.85 further. Yes, Ahmad, right?
8.8541 8 into 10 raised to minus 7.
8 into 10 to the power
minus 12.
minus 12. Yes, correct. 8.85 into 10 to the power minus 12. Yes, this is the value. Please class, all these are very basic values. Mu naughts, epsilon naughts value, speed of light, all these are very basic because in your exam you have to use these values, right? You have to put in all these values. So please remember this exactly, specifically this 8 epsilon naughts value, because mu naught you can put 4.10 to the power minus 10. You don't need to multiply and check 12.36 is it coming or not. But these two values separately you should remember, because in magnetics entire lesson is based upon this. Your complete electrostatics is based upon this, right? Where you put the constant, or even in Coulomb's law you put it to 1k is equal to 1 by 4 by epsilon naught. So you will be requiring epsilon naught. Anyways, this came out to be 3 into 10 to the power 8 meter per second as per this formula. So this formula was derived. But this is the speed of electromagnetic wave in vacuum only, specifically in vacuum only. Now, speed of EM wave in a medium. Speed of EM wave in a medium. If I change the medium, if I'm not talking about air, vacuum is removed. Any medium can be there. A glass is there. From a glass, any ray of light can pass through the glass, piece of glass. In ray optics, we'll be completely using glass everywhere, from air to glass, glass to air, all these media. So what happens? It means EM wave speed will not be there. Definitely some speed will be there, but a slight change will be there. So C is equal to 1 by under root mu epsilon will come. Now what is mu? What is epsilon? Mu is permeability in some other medium which we are referring. Epsilon is the permittivity in the medium where we are referring. Mu naught, mu r. This we had seen when we did chapter 5, magnetism and matter. Mu is equal to mu naught into mu r. That is permeability in some medium. Permeability, this in some medium, is equal to permeability of air multiplied by relative permeability. Same thing, permittivity in some medium is equal to permittivity in air or free space multiplied by the relative permeability. This was what we had studied in the first lesson and as well as in the 5th lesson. This is the relation. So we'll put it here exactly. So V dash, let's say, yes, V dash, or let's take VM, V medium, it will become speed in the medium. So VM, let's take speed of EM wave in the medium. This will now be epsilon can be written as mu naught into mu r. E, that is your permittivity, epsilon. This is written as epsilon into epsilon r. So mu can be written as mu naught into mu r, and epsilon can be written as epsilon into epsilon r. Now, if I separate these terms within the bracket only, if I want to write mu naught and epsilon naught together, and I want to write mu r epsilon r together. This is which term? Just now I have told you 1 by mu naught epsilon naught. This is some term. What is exactly this? We just did it.
Speed of wave in vacuum, that is 3 into
Yes.
10 power 8.
Perfect. That is speed of light. This is exactly the formula for speed of light. It means the speed in some other medium becomes C by, that is speed of light by mu r into epsilon r. No numerical will come from some other medium. Numericals do come from this. Numericals do come from this. C is equal to 1 by mu naught epsilon naught. Using this, it can come more than this even, because this is fixed. Speed of light will come. E by B is equal to C. From here, you can get a question. Otherwise, questions from here are very simple. Before we move on to 5th point, write these 4 points. Any doubts you have in these 4 points, then we'll clarify and discuss it. First, get these 4 points clear. Then we'll do the other remaining points. See, these fifth and sixth point that we'll discuss in optics only. This actually relates with your refractive index. So since we have not done refractive index and optics, we have not started with, let's leave these 2 points. You can copy it down when I'll write it, when I'll give you time, because these should be together in your notebook. All right, let's come to the 7th point. 7th point is the most important point. Energy density. Separate questions even come from energy density, only separate questions. Fine. So whenever you're writing this, do mark it is important in your notebook, because energy density from electric field, magnetic field, total energy density, this comes a lot. This can come separately. Otherwise, rest from rest of the points, E by B is equal to speed of light, that can come separately, and this can come. Otherwise, rest of the things can come together, right? Like write the properties of electromagnetic waves. So you have to mention all the points. 7th is a longer, when if it comes in your continuous para, like write the properties of EM waves. Then write it in short, just the first and second line. No need to write everything, but if it comes separately, numericals also can come separately, then you have to mention. See, electrical density and magnetic density are actually what? Your energy, total energy is made up of electric fields energy and magnetic fields energy. Electric fields energy, the formula for electric fields energy, this is half, fine. Remember like this only, because you have to relate and connect it with magnetic fields one. So this is half E square into epsilon, half epsilon naught E square. For magnetic fields energy, this is not electric field actually, this is their energy. So you can write it as energy of electric field, energy of magnetic field. So this is half B square. Now this is not multiplied by mu naught. This is divided by mu naught. So like this, remember the form. Half E square into epsilon naught is equal to half B square into mu naught. Now what exactly is this E and B? Means this is the ERMS value. ERMS, which we say root mean square value. So this is exactly that E square and B square's value. Now total energy will be what? If you have electrical energy density basically means energy divided by volume. So total energy will be what? Electrical energy density plus magnetic energy density. So that becomes UE plus UB half epsilon naught E square plus half B square by mu naught. And what did I tell you? These are ERMS value. Even if you have RMS value, these are same. Just in case, if you have to write about the peak values, then you can write, you already know ERMS is equal to what? E naught by root 2, right? So ERMS square will be what? E naught by 2. Similarly, BRMS is equal to B naught by root 2. So BRMS whole square will be equal to B naught by root 2. Not root 2, only 2. Now what will be the total energy density? In this equation, no, ERMS and BRMS one. Put these values of ERMS square and BRMS square. So total energy density will become what? This is equal to E is equal to C. Here total energy density for the ERMS one. This is half. Instead of ERMS square, I can write it as E naught by 2, right? E naught square by 2 I can write. A square will also come. No, we are squaring it. Here one square will also come. Here one square will also come. So this is ERMS square into epsilon naught plus half BRMS square. What is BRMS square? It is B naught square by 2. And in division you have 1 by mu naught. So what will become your total energy density? 1 by 4 E naught square epsilon naught plus 1 by 4 B naught square by mu naught. This becomes the total energy density. Now this you will use if peak value is given, and if your RMS values are there, then simply use half. So just 4 becomes 2 in this equation. Now comes the question of momentum. What is momentum in case of electromagnetic wave? Otherwise, you know your momentum. Momentum is what? Momentum is the product of mass and velocity, right? Mass into velocity is momentum. Here you have a different definition of momentum. Momentum is the total energy divided by the speed of light. Total energy divided by the speed of light. So this is simple, but what you have to remember over here is formula of force. In your class 11th, you must have done force is dp over dt, Newton's second law. This was Newton's second law, if you remember. Force is rate of change of momentum. Rate of change of linear momentum is force. From here we derived F is equal to MEI's formula. If you write momentum, F is equal to P by T, this is where T is your time. This is for an absorbing surface. Now what is meant by this? Absorbing surface and you have reflecting surface. So see, absorbing surfaces are there and reflecting surfaces are there. This is a surface you have, or let's take both the cases together only. This is one surface and let's take the second surface together. So I have roughened it from one part and I have roughened it from another part. If a ray of light, this a ray of light strikes over here. EM wave, electromagnetic wave strike, whose momentum is P, time duration is T. So I can write F is equal to P by T. But see, now this is for absorbing surface. If I say I am talking about a reflecting surface, so from the reflecting surface, it will once come and it will move back. It comes from the absorbing surface. And if it is a reflecting surface, then the ray of light which has come, it will go back, it will get reflected. This is the absorbing surface case. Now look at this second case. Just focus on this case right now. Remember the way we perform sign conventions for relative velocity, similar things you have to remember. If let's say this is the momentum for this and this is the momentum for this. So I have to use sign convention. Let's say I take one side as positive and the other side I have taken as negative. Let's say downward I have taken positive, so it means upwards I have to take it as negative. So what will be the total momentum that I'll write? Total momentum or change in momentum will be final momentum minus initial momentum. That is what is change in momentum. Final momentum is P, right? And initial momentum is minus P. So you get P minus P. So that becomes 2P. So that's why the force becomes 2P divided by T for a reflecting surface. It's like relative velocity. I'll give you an example. See, when we do relative velocity, for discussion of relative velocity, let's say a car is moving with a speed of 5 meters per second. Another car is moving with a speed of 3 meters per second. If both the cars are moving in opposite direction, fine, this I have taken the case, both the cars are moving in opposite direction. Now see what will happen. One is moving towards one side, right side with 5 meters per second, other is moving with the speed as 3 meters per second. If I do not consider the sign convention, net velocity will be what? Simply 5 minus 3, that will give me 2 meters per second. Net velocity will be what? 5 minus 3 is equal to 2 meter per second. If I do not consider any sign convention, this will be the relative velocity v1 minus v2. But if I consider the sign convention, if I take the sign convention, let's say if I choose that this side is negative and this side is positive, let's say I've chosen the sign convention. Now what will happen? B net will be what? This will be 5 minus, this is not 3, this is minus 3. So that becomes 5 plus 3, which will give 8 meter per second. Do you see this difference between this 2 and this 8? This is subtraction, simple. This is vector subtraction. Here also we did the same thing. Why it is 2p for a reflecting surface? Did you understand? Because of the sign convention. So that's why I didn't write the formula straight away. F is equal to 2p by t, because there was the reason behind this. And last is energy. Energy is intensity. Intensity is simply definition of intensity. This is a energy per unit area per unit time. And even if you write the SI units for energy, you know it is joule. For area, you know it's meter square, and time is seconds. So you can write it as joules per meter square per second as well. But if you are able to recall this, can you tell what is joules per second? Anyone who is getting an idea what is joules per second? Ever heard of this? Joules per second. Energy per unit time, or joules per second. Yes, Samad, can you try?
Yes. Is it 1 watt or?
Yes,
One.
but power. Yes, very good. It is power. Energy per unit time is power. So this becomes watt. This will be watt. Watt per meter square. So SI unit of intensity can be joules per meter square per second also. You can write the SI unit as joules per meter square per second as well. Or best way is to write watt per meter square. Use watt per meter square because most of the places it is watt per meter square that is written, because power also is written as joules per second. Fine, so that was intensity. First, tell me this. Have you understood this point or not? All the points of this.
Yes, ma'am, understood. Ma'am, you stopped sharing.
Yes, yes, just give me a second. I think there's some issue over here. Just check whether the screen is sharing now or not.
Yes, ma'am.
It is? Okay. Write it from here only then. Yes, I was asking you all that. Yes, did you understand that point? Why force is P by T, and for a reflecting surface it becomes 2P by T. Did you all get that point? Clear or not?
Ma'am, could you just explain that once again?
Yes. See, momentum is energy divided by speed of light. So formula of force is P by T for an absorbing surface. I think this is clear. This is just Newton's law. If I say one ray of light has struck one surface and now it is going back. So you have to take sign convention. Like if you're taking upwards as positive, you have to take downwards as negative. Let's say initial momentum was P. So final momentum will not be P. It will become minus P. That will tell you that it is in exactly opposite direction. Agreed or not?
Yes, ma'am.
Yes. So now if you take the net momentum, it becomes, instead of P minus P, it becomes P minus minus P. P1 minus P2 here, your P2 is not P now, it is minus P. So that becomes P plus P, which is equal to 2P. The way in relative velocity we take, the way the example which I gave you, 5 on one side, 3 on one side. If you directly subtract it, that becomes 2. But actually your answer is not 2. That becomes 5 minus 3. So that becomes 8. Like this only. Here it gets added. That's why we write 2P by T. So it actually becomes double. Clear now?
Yes, ma'am.
So all of you note down all these points. Wherever you're not able to understand, ask me then and there.
Ma'am, could you show the fourth point again?
Ma'am, could you scroll up to the sixth line again? Yes, ma'am, you can scroll.
Ma'am,
Yes, Astha.
ma'am, here B represents what?
Magnetic field. Magnetic. B is always
And
for magnetic field.
B naught?
B naught is for the peak value of magnetic field. See, B is the symbol for magnetic field. Now, if you take the root mean square value, that becomes BRMS. Why are we talking about RMS and not peak value? Because your variable magnetic field exists. This is not your magnetic field from magnetism that you can say this is 4 Tesla, that is 5 Tesla and over. No, here your magnetic field is depending upon time. It means for different values of time, you'll be having different values of magnetic field. So if you take the mean of all these, if you calculate the root mean square by taking the average and squaring it and taking it under the root, that is BRMS. And among all the values that you have obtained for all the different time intervals, among that, the highest value, which you call the amplitude, peak value, that is representing your B naught. Clear?
Yes, ma'am. Ma'am, by when we'll complete all the chapters?
By in the next class, most probably displacement current we'll complete, and we'll start with ray optics in the next class only. Ray optics will take time. Apart from ray optics, in your syllabus will go faster, because in other batches ray optics has been completed, so the syllabus is now going very fast. So majorly we have ray optics that we have to deal with. So ray optics will take time. If the other batches classes get completed soon, then I'll increase your time. But you have sufficient time. I think 2 hours class is enough for weekend. We'll be able to complete the syllabus by this month. Will completely go. December first week, I hope we should be able to complete the syllabus. At least December 1st, 2nd week. All right, Asta. Then we'll start with the revision. I'll try to complete it in the first week only. Because now see, October is ending. We'll start with, we have the Sunday, no? 30th is gone. Then we have directly classes from November. So many classes of November will be required for ray optics. Then the syllabus will be having for one class only, because from your syllabus now more things have been deleted. So most probably by first week of December. Also, let me know your pre-board schedule class. Pre-boards, pre-boards will keep on going, no? We'll be having here the tests also. Today's test, yes, Asta, say.
Ma'am, my pre-boards is 30th November is physics exam.
30th November. Okay, so Asta, you can do one thing if you are available, because I don't know what's your schedule. I have to check in the report section, whatever is your schedule in the management. I have to look up, because I don't remember in which batches you are there for the subjects. In other batches, you can do one thing. You can start from wave optics in other batches and keep on completing ray optics in the weekend duration. This also thing you can do. You are allowed to do, but you should have the available time left in your weekdays. Because in the weekdays batches, 1 or 2 in 2 batches, we are going to start with wave optics. So second book's completion you can do in the month of November, if you can attend it. All right, Asta.
Yes, ma'am.
Ma'am,
Yes, Anushka, say.
ma'am, in our school, our first mock board exams will be in first week of January, first week of December, and then second mock exam will be first week of January.
Acha, so first week of December, first week of January. Yes, that's fine. Then. That is perfect. Then. Because here this should be the schedule: first December and then Jan. Okay, then I think Anushka, you will be able to prepare it, because let's see how the ray optics go.
Yes, ma'am.
Yes, let's see. This is your weekend batch which we are having it. So what you can do, if you have time, as I was discussing this with Astha only, if you have time, I let you know whatever you have, what's your schedule, whichever batches you are enrolled into, whichever subjects, and especially which teacher is taking. Your second book's wave optics is going to start from the other batches. I think this is what, Sunday, no? So from tomorrow only, new batches are going. New chapter is going to start. So students who are having their boards, this midterm and these pre-boards immediately at the end of November, you all can complete wave optics, semiconductor, and modern physics within this month, and keep on completing your ray optics in this batch, because ray optics is a very huge lesson and very important lesson. And this time this has also increased. Reflection is already at. So you can do one thing: if you have sufficient time to join the batches, attend the classes of that batch and be with that batch. It means you have to appear for the test also for that batch, rest of the things. So if you have time during the weekdays, then let me know. Otherwise, I think by the first week of December here also it will get completed, most probably.
Ma'am, what's the timing for that batch?
There are two batches. In which state are you? Are you there in India, Zaid?
No, ma'am, I'm in Saudi.
Okay. So for you, it's from, we have it in 2 days. Let me write you the schedule. One you have on Monday and Wednesday, that we have from 9 over here in India. So that becomes 7:30 for you all. 9 p.m. here becomes 7:30.
Yeah.
7:30, no? So
No,
that is
6:30, 6:30.
6:30. So 6:30 to 8:30 you have on Monday, Wednesday. One batch is there for Tuesday and Thursday. Both the batches have the same pace going on, almost wave optics are going to start. So for Tuesday, Thursday, you have, I think it will be 4 o'clock. 6:30 of IST is 4 p.m. no? So that will be 4 p.m. So 4 to 6. These are the timings. Just see if you are comfortable, if you will be able to join. And if you are joining, that means you have to do the assignments, that you have to attend all the tests.
Ma'am, can you scroll up for a second? Ma'am, here F denotes what?
Force. Force is equal to
Okay.
momentum by time.
Ma'am,
Yes, yes, Asta, sir.
ma'am, the chapters after ray optics, they are like very small chapters, right?
Very, very small chapters. Wave
So
optics.
they're not that important, right? After ray optics, like it will be like lesson.
No, no, important to hai. Nahi, they are important. See, because they are scoring chapters. Like even if you get stuck in ray optics, no, there are chances you can get stuck in ray optics from book 2. Other chapters will help you to boost your score, especially all these modern physics. They will take one day class, atoms one class, nucleus one class, radioactivity be delete ho gaye, so you don't even have radioactivity now. So all these things are reduced. That's why I'm saying no. Since the only time that has to be taken now in your batch is just ray optics. Ray optics gets completed, one class for the other chapters. Not for wave optics needs 2 to 3 classes, but the other chapters, semiconductors, only PN junction is there. Last year some things else were also there. This time that has also been deleted. Only rectifier and PN junction is there. Topic for a single class. 2 hours class is enough. Like this. The way EM waves is also a very small lesson. You can even see. Today we started it. Technically, we had started it today only. No, yesterday we just introduced it. Next class it will be over. If you didn't have your test today, I would have completed it. Displacement current is a small topic. So all these lessons that are there, they are very small. Second book will get completed very fast. That's what I'm saying. Second book will get completed very fast. It's just that we have to have a good time for ray optics. So your syllabus is now stable. Once your EM waves is over, let us just go into ray optics. Ray optics will take time because we'll do it in detail. It's a very important lesson. After ray optics, the lessons are smaller only. They are not lengthy. All these lessons are smaller. But yes, you cannot neglect it because your whole score, no, you will only notice all these lessons, easy lessons, no, will help you boost your score because you can get stuck in electromagnetism, electrostatics, and magnetic effects of electric current. All the first 4 chapters, you can get stuck in the resistors, circuits. But these questions are obvious, which will come from second book. Okay, Asta.
Yes, ma'am.
Don't write this velocity example.
Ma'am, the test is of how many marks?
Test marks, I think optional questions are there. 10 marks or 15 marks, optional questions are there. Let me just show you. Quickly write it down, class. Let me just share this paper.
Sir, ma'am, here in the SI unit, you have written what it's to, I guess.
Yes, yes. What per second? What per second?
Ma'am, here also.
Yes, yes. Power, energy per unit time. Actually, the screen which I was sharing, some error had occurred over here, which I had written just now in this class. So this part was actually covered in some other batch. So I had to take that out, not the one that I prepared for you all. So that's why this was written, I think, time back. Done all, just text me done in the chat column.
Ma'am, here watt per meter square into second. It is joule, right?
Oh, yes, you were referring to this. No, yes. This is Joule. This is Joule. This Joule per seconds is what? Energy by time is power. Okay, I think most of you have completed it. Let me show you your test sheet then. Also from the next classes, next tests, whenever we have the next test, you will be asked to open your camera, since many students were not aware. That's why I didn't force you to open your cameras today. From the next classes as well, you have to open your cameras and sit. So please make sure also the focus mode is on, so nobody will be able to see you, and if except for me, and you will not also be recorded in the recordings that are taken. So do not worry about that. Because in the class, most of the times I'm calling students' name and they are not responding. So you have to now open your cameras. If there are any issues, let me know. And for the test, so definitely you have to. Even for the class, I can accept some things, but for the test, you have to open up your videos and then answer.
Yes, ma'am.
Do one thing, class. I think not so much time is left. Don't do one of these. I think let me just cut this one. Perform this one. One of these, so 3 questions. First is this very short question, very short. Then you have this question, one of these, whatever suits you. And last is this derivation. Yes, Ed, you can leave.
Ma'am,
Haan, Anushka, say.
ma'am, can you copy the questions in the chat box because at the screen went a bit blurred.
Sorry, can you repeat it, Anushka?
Ma'am, I was saying that could you copy the message in the chat box, the questions in the chat box because the screen went blur for me.
Screen is blurred. Right now also?
Yes, ma'am.
Acha, okay, then let me. For others also, this is blur.
No, ma'am. For me, it's fine.
It's fine, no? So can one of you do one thing? Can you take the screenshot and send me on WhatsApp the group? So I'll share it with both the groups if anyone is having difficulty. Imad, can you do this thing? Just send the screenshot or anyone. An attempt?
Ma'am,
Yes.
to your personal number or group?
Wherever. I'll share in both the groups then. I think Anushka, that is better if you can access because in this chat it will become difficult.
Ma'am,
Hmm.
for the first question, it's RMS value. That's like IRMS or ERMS.
IRMS. Current time graph is there, no?
So, okay, thank you, ma'am.
Thank you, ma'am.
Okay, thank you, Imad. Imad has sent it. I'll share it on the girls group as well.
Ma'am, should we do the questions 2 and 3 both, or is still an option?
1 of 2 and 3. Either,
Okay.
whichever you think. So 3 questions you have to do. First is compulsory, 6 is compulsory, 4th, 5th I've already cut. Do 1 of 2 and 3.
Okay.
Ma'am,
Yes, Asta.
ma'am, for the last question, the
Mhm.
derivation. You have to write only the expression or like derive.
Derive the expression. Derivation है तभी तो expression.
There
Derive the
are
expression.
two, I mean, we have learned like,
One formula you have for the derivation of Q factor. One derivation we did, no? From which we concluded two formula. So
yes,
write that
ma'am.
one single derivation where we took two equations, we added, then subtracted, that part only. That is one
Okay,
single.
okay.
Whenever even in your exam it comes, no. Then also for Q factor, you have to write down. That's why 6 marks are there. And do write the definition. What do you mean by Q factor?
Yes, ma'am.
All those who have completed, and as you will keep on completing it, you can send it on the group. Try to send it on the group only if you all are added. Because see, and those who are not added, please get yourself added. Because when I check the sheets, it becomes difficult to find it out from my personal chats. So if it's there on the group, I just check the date and once it comes. So please try to submit it on the group only.
Ma'am,
Yes, Anushka.
ma'am, for the sixth question, if we just write the meaning of the Q factor, how many marks will be given?
See, meaning only you have to write meaning with that graph. One graph we had written, so that graph that has the marks. Mean the marks. One marker this is, so you don't have to write much. Mean the derivation is for 5 marks and this is for 1 mark. So in 1 mark, whatever you think should be written, write it. Otherwise, make the graph also. I'll suggest you for a complete score, it will be better. One graph, no, we had drawn that one.
Yes, ma'am.
Hemad, yes, PDF will be better. Just compile all your pages in PDF and upload it with your name. The PDF's name would be your name, or you can mention your name separately. Jiva, have you submitted your PDF? Just share your PDF and then you can leave. Once you've completed and share your answer, then you can leave.
Ma'am, did you receive mine?
Astha's. Astha, yes. Thank you, Astha. You can.
Thank you, ma'am.
Ma'am, I have completed the paper. Like, where should I send paper?
Ahmed on the group only? Voice group is there, no?
Okay, ma'am.
You're there, no? On the
Yes, ma'am.
okay, there.
Ma'am, I've sent my paper as well in the group.
Yes, Anushka. Thank you, Anushka.
Ma'am, I may leave.
Yes. Thank you so much. Bye bye.
Thank you, ma'am. Bye, ma'am.
Someone has sent it on the group. Physics test PDF. Who has just sent it?
Ma'am, I have sent that paper on the group.
Okay, this is Imad. Okay, yes.
Ma'am,
Imad and Ahmed both have submitted.
yes, ma'am.
Yes. Thank you. Both. Thank you so much.
Thank you.